So we ended our last lecture on 7.3, which is bone development and growth. We did look at the effects of vitamins A, C, and D and their deficiencies. We also looked at growth hormones, such hormones as the thyroid hormones, T4, thyroxine, calcitonin, parathyroid hormone, abbreviated PTH, and also the sex hormones, and also physical stress and exercise on the skeletal system itself. We are going to continue our lecture in 7.4, which will conclude our discussion of the skeletal system and its physiology on bone function. So basically, we know that bone function itself, basically, it's for support, protection, and movement. Bone shape, support and protect body structures. Um, Basically, if you look, support the bones in the legs and the pelvis are going to support that of the trunk. The atlas, which is the first cervical vertebrae, that's going to support the skull. For protection, you have the underlying organs. The skull is going to protect the brain, and the rib cage protects the heart and the lungs, etc. So the rib cage is going to help protect the thoracic cavity and the upper abdominal cavity. For body movement, the skeletal muscles are going to be attached to bones by tendons, and ultimately this is how we are going to have movement. So essentially, the bones themselves are going to serve as levers for movement. So when we get into articulations, our next chapter, we'll talk about a little bit of mechanics with physics, and talk about levers and the fulcrum, and how those how the bones and the muscles work together for movement. We also have blood cell formation. Blood cell formation is hematopoiesis. It occurs in the red bone marrow. That's where you have uh, blood cells forming. So all blood cells are formed in the red marrow of certain bones. If you look, here's a hematopoiesis blood cell formation. You could see pictures of erythrocytes. Those are the red blood cells. And then you also have white blood cells there. And the two that are illustrated here are the neutrophils, which are right here. Look at those nuclei. And then you also have platelets that are embedded in here. Remember, erythrocytes themselves, red blood cells, are not nucleated. The next thing that bone functioning, it's an inorganic salt storage. Inorganic salt storage, the most abundant salt is calcium phosphate. That makes up hydroxyapatite. We've learned that earlier in one of the lectures. Hydroxyapatite, spelled Hydroxyapatite, which is primarily calcium phosphate. That calcium phosphate is going to give bones its hardness or rigidity. Calcium is required for many metabolic processes, including muscle contraction and nerve impulse conduction. We will look at how calcium plays a role in both those processes. Blood calcium homeostasis must also be maintained because bone remodeling directly affects blood calcium homeostasis, because the primary matrix of bone itself is that calcium. You do know that osteoporosis is a condition that results from loss of bone mineral. They do say that if you eat a lot of broccoli, some other really good greeny leafy vegetables, that helps with bone strength due to calcium. Also, some of your dairy products. Also recall that once bone is formed, it is continuously being remodeled throughout life. The process involves the action of both those osteoblast and osteoclast, two hormones, the calcitonin and the parathyroid hormone, and in turn also will affect the blood calcium homeostasis. Recall that parathyroid hormone PTH, which is secreted by the parathyroid gland when blood calcium levels are low, is going to stimulate osteoclast activity, which would reabsorb which allows for the reabsorption of bone, which releases calcium 2 plus ions into the blood. So PTH stimulates osteoclast activity to release Ca2 plus into the blood, and this will cause the kidney tubules to reabsorb that calcium 2 plus back into the blood. It causes intestinal mucosa to increase dietary absorption of Ca2 plus, and therefore causes an increase in blood calcium levels back to normal. Calcitonin, on the other hand, which is secreted by the thyroid gland when the blood calcium levels are high, is going to inhibit bone reabsorption and increase osteoblast activity. Therefore, it's going to cause a deposition of bone matrix. So it's going to deposit bone matrix, and ultimately that causes those kidney tubules to secrete excess 2 plus into the urine, and therefore results in a decrease in blood calcium levels to restore back to normal. So this is an example. When you look at PTH and calcitonin, here you're looking at a negative feedback loop mechanism to restore things back to their normal levels. I will draw out this diagram on the board in class for you to be able to see, but ultimately the normal blood calcium levels has a set point of about 8.4 to 10.3 deciliters. So you could see how that negative feedback loop mechanism helps maintain inorganic salt and blood calcium homeostasis. Well, ultimately that ends our discussion. The rest of it is just the breaking down of the skeletal system, looking at both the axial and appendicular skeleton and studying their features. I do recommend maybe going on to Anatomy and Physiology Revealed. You have access to that site, and you could learn the body parts, highlight the body parts of the skeletal system, the bones and their features, and learn more about them there. So that is a great resource to be using as we come to our lecture exam and our lab practical on the division of the skeleton and its physiology. Thank you, everybody, and have a nice day.